Good day, dear Lena Tom. Today we're going to be looking at computer networks. So we're going to be looking at the first part of computer networks. So we're going to be defining networks first, looking what a computer network is. So a computer network is two or more computers or other electronic devices connected together so that they can exchange data. Networks allow computers to share files and resources. As you can see in this picture, we are able to share the printer right here on our network. We can also share the database here from this database server. And if you can notice, there are many different types of computers. We can have a desktop computers here, laptop computers, and PDAs, maybe in smartphones sharing one and the same network. So we are now going to further look at the most common network devices that we have. The first one is the router. Routers are hardware devices that read the address information to determine the final destination of packets. Let's say you are sending data to another computer, so the router will determine where that data is being sent to. Each computer linked to the internet is given a number which is called Internet Protocol address, IP address. This address has a three digits number. Okay, it divided into four. First three-digit number, the second three-digit number, and then the last two are also three-digit numbers. Okay, and is unique for each device. So each network device on the network has a unique IP address. The data is transferred from one network to another. The data When data is transferred from one network to another, the data is put into packets. So it is put into packets. The packets contain details of the destination address of the network it is intended for. So if I'm sending a file from the internet from my device to your device, then it will use the IP address to determine which device I want to send my file to. Computers on the same network have the same part of the IP address. So if I have computers in a computer lab at school, then the first part or the first three parts of the IP address have to be the same. So for like in this example in that I have given here, above 192.168.8 should be the same, and then maybe the last part should be different because we want a unique number for each IP address. The router is able to send the data to the appropriate switch, and it will then be delivered using the media access control address destination. If the MAC address does not match with any device in the given network, the router passes it to another switch on the same network until the appropriate device is found. So the media access control address is a unique address for, or a unique number for each and every network device, be it your smartphone, be it your desktop computer, be it your laptop. Routers can also use to join wired or wireless networks together. Routers are used to connect a local area network to a wide area network. We'll talk about the local area network and the wide area network in detail in the coming videos. Or it can also be used to connect to the internet. So for us to connect to the internet, we need a router. Okay, the next device we're going to be looking at is one that is similar to the router, a modem. Modem simply stands for modulator and demodulator. Modulator, demodulator. A modem is a device which converts or modulates a computer's digital signal into analog signal for transmission over an existing telephone line and analog to digital signal, or demodulates to enable a computer to process the data. Modems are used to allow computers to connect to the network over long distances using telephone networks. Dial-up modems operate at a speed of 60 kilobits per second, which is very slow. So modern broadband or ADSL asymmetric digital subscriber line modems operate at 100 megabits per second, which is very fast. Okay, another network device that we have are the hubs. A hub is a hardware device that connects computers together. They are often used to connect together a number of devices to form a local area network. Its main task is to take data which it receives through one of its ports and then sends out this data to all the other ports. Each computer or device will receive the data whether it is relevant or not. It is usually used at the center of a star topology. Okay, we won't be talking about topology in this syllabus. Hub is a dump device. If it receives a message, it sends it to every computer on the network. This means that hub-based networks are not very secure. So the next computer network device we're going to be looking at are switches. A switch is like a hub. It is a device which connects a number of computers together to make an LAN. The switch has cable plugged into computers to connect them to a network. A switch is more intelligent than a hub. If it receives a message, it checks to which computer it is addressed and sends it to that specific computer only. Because of this, networks that use switches are more secure than those that use hubs, but they are also a little more expensive. So switches are more expensive than hubs, yet they do an almost similar jobs. Since the hub only sends packets of data to specific computers, it reduces the amount of data on the network, thus speeding up the network, which means switches are faster than hubs. Since each device or computer on the network has a media access control address, a MAC address, that uniquely identifies it, data packets sent to switches have a MAC address which identifies the source of the data and additional address that identifies each device that should receive the data. Another network device that we're going to be looking at are the bridges. Bridges are used to connect LANs together, local area networks together. When one of the LAN sends a message, all the devices on the LAN receives the message. This increases the amount of data flowing on the LAN. Often, a large LAN is divided into series of smaller LANs. So we can have a large LAN but divided into smaller LANs. If message is sent from one computer in an LAN to another computer in a different LAN, different local area network, the message needs to be passed between the two local area networks using a bridge. A bridge, therefore, usually has only two ports in order to connect one LAN to another LAN. So the bridge connects two LANs together. And then another network device is or are the network interface cards. Network interface cards, sometimes called or referred to as NICs. A network interface card is needed to allow a device to connect to a network, for example, the internet. It is usually part of the device hardware and frequently contains MAC addresses generated at the manufacturing stage. So they are manufactured with MAC addresses. So network interface cards come with their own MAC addresses. Many computers or laptops come with a pre-installed network interface card. Okay, the last devices or that we're going to talk about, network devices, are network computers. Even though many computer systems now use what we call Wi-Fi networks, cables are still used because they have the following advantage over wireless networks. They have faster data transfer rates. They are more secure than wireless networks. The cables can either be copper or fiber optics, with fiber optics offering very high data transfer rates and also better security. We have come to our end of the video, so you can follow us on the following websites: www.eictta.com or www.facebook.com/SICTTA. Thank you very much. See you on the next video.